Hey everybody, Dr. Phil here. So this is going to be a video on computer networks and the internet. So let's go ahead and jump right in. So let's start by talking about what is a network. This is probably something that most of you already know. So a network is more formally defined as a group of two or more devices, computers, connected together to allow for the exchange of information and for the sharing of resources. Many computer networks are linked together and supported, of course, by the internet. Computer networks support many different software applications and services, including allowing access to the World Wide Web, digital video and audio, storage, application servers, and of course, email. So, with regard to computer networks, a network is a group of two or more devices, computers connected together to allow for the exchange of information and for the sharing of resources such as printers. Right. So generally speaking, there isn't like, if you think about like a typical office, it isn't like for every computer, everybody has a printer. There's usually, maybe one printer in the office, or if it's a big office, maybe there's a couple, but it's not generally the case that everybody has their own printer, right? So with respect to network size, networks range in size from small home networks to the internet, which is of course the world's largest network. So the benefits of networks. Networks provide many benefits, including allowing users to share resources and the ability to access other networks, and of course, the internet itself. So the four basic type of networks include what we call a PAN, personal area network. So this is typically going to involve, your laptops, tablets, and smartphones. The next type of network is called a LAN, local area network. This is where we connect a variety of devices at a single site, such as an office or retail store. And then what we call a WAN, a wide area network, where we can connect a variety of devices between two or more geographic locations. And then finally, the internet, where of course we connect LANs, WANs, and other types of internets together. So think of an internet as like a network of networks. And of course, the World Wide Web is the world's largest network. So let's talk about the components of an IP address. So an internet protocol IP address is a unique number that identifies a device on a network, allowing it to send and receive data. So some key points of IP addresses. Think of an IP address much the same as your home address. In order to receive mail or packages at your home, the sending party must have your mailing address, in this case IP address, in your town city, and again in this case network. Without a specific IP address, information cannot be received. IP address can be assigned permanently, known as static, for example, email servers, businesses, permanent home address, etc., or from a pool of available IP addresses that are assigned by your internet service provider, typically abbreviated ISP. So let's talk about sending information on the internet. Computers and other digital devices connect and communicate on the internet using what we call the Transmission Control Protocol, Internet Protocol, TCP/IP. TCP/IP is a system of rules listed step by step that each computer connected to the internet uses to communicate with each other. To connect to the internet and other computers on a network, each device must have a network interface card, what's known as an NIC, installed. A network cable, or wireless technologies, must have access to a modem or router in order to access the internet. So what about the World Wide Web, the WWW, right? So the World Wide Web, commonly referred to as WWW, or the web, is an interconnected system of web pages accessible through the internet. The World Wide Web consists of various components, including Hypertext Transfer Protocol, HTTP. This is a protocol for the transmission of hypermedia documents, such as HTML. Uniform Resource Locators, URL. URLs are one type of uniform resource locator. There are also other ones. And then Hypertext Markup Language, HTML. This is a commonly used format for publishing web documents and content. And then Geographic Information Systems, GIS. These are built on a foundation provided by the Global Positioning System, GPS. So GPS is a navigation system that uses at least 24 satellites to help people find their way across the globe. GIS allows for the analysis of spatial data including geospatial data and geographic information, which is used for more informed decision making. Geospatial data is data about items, events, or phenomena that have a physical location somewhere on the surface of the Earth. Spatial data identifies the geographic features found on Earth. And then with respect to how are geographic information systems used in business? So GIS systems are focused on the capture, analysis, use, and management of spatial location information. GIS is rooted in the science of geography and seeks to integrate many types of data to create visualizations using maps and 3D scenes. Enhancements to GIS software and practices have allowed businesses to get real-time access to a wide variety of geospatial data. So what about cellular phone communications? So cellular communication via phone may seem like a complex process, but essentially a cell phone is just a two-way radio consisting of a radio transmitter and a receiver. When you place a call on your cell phone, the phone converts your voice into an electronic signal that is transmitted via radio waves to the nearest cell tower. Once the call is received by the nearest tower, it's relayed to a system network of cell towers, where it's then converted and received by the phone you were calling. When the person on the other phone accepts the call and begins to speak, that person's voice is converted to an electronic signal that is sent back through the network until it is received and converted by the caller's phone. So it's just going back and forth, these series of electronic signals. Now, you may or may not have heard of what we call IoT, the Internet of Things. So in the broadest sense, this just refers to everything that's connected to the internet, which it could be, your thermostat in your house, your fridge, so on and so forth. So IoT is increasingly being used to define objects connected to the internet that talk to each other, including sensors, wearable technology, and smartphones. It's estimated that there will soon be over 30 billion IoT devices across the globe, and that over $3 trillion was spent last year on endpoints and services. Cloud computing is a computing model where processing, storage, software, applications, and a variety of services are provided over a network, mainly accessed via the internet. Cloud computing removes the need to have data, files, and software stored directly on a device. Cloud services include Apple iCloud, Google Drive, and Microsoft 365. Google and Amazon Web Services, sometimes abbreviated AWS, offer cloud computing centers that can assist organizations with data storage and management, applications management, and increase computing power which can be maintained remotely outside of the organization. SAP and Oracle offer software applications that are delivered via the internet and accessible to employees in various locations. So web services are a set of software technologies that are able to exchange information with each other using standardized web communication protocols and languages. I'm sorry, I think I just skipped one there. Let me go back. There we go. So what are some uses of web services? So web services can be used to create apps that link different systems of different organizations and to build open, standard-based web applications. One of the technologies on which web services are based is XML. So XML stands for Extensible Markup Language and is a set of recommendations from the World Wide Web Consortium, also abbreviated W3C. XML is a markup language that is self-defining and is designed to be both human and machine readable. And finally, software as a service, or sometimes abbreviated SaaS. So software as a service is a cloud-based software service offered by vendors and hosted on a vendor's cloud that allows users to access a software application using a web browser and internet connection. With SaaS, you simply access Microsoft Office applications using a web browser and an internet connection. And a great example of SaaS would be, Google Apps. So things like, Google, Google Sheets instead of using, Microsoft Excel. You don't have to have you don't have to have Excel. You don't have to have a specific, spreadsheet application. You're able just to use, what you're using on the web. All right, thanks for watching this video, and as always, I will see you all in a future video.